Hi there! In today's video, we're going to take a look at how we can use the built-in Phaser 3 game objects and Phaser 3 texture manager to draw images to our HTML canvas element using the 9-slice image scaling technique. The Phaser 3 library is very powerful and provides a number of built-in features for drawing images to your HTML canvas. However, when you want to scale an image and draw that image without it looking stretched and distorted, this can be a little bit tricky. A good example can be seen here on my screen, where we have this nice UI border image that I want to go ahead and scale up. However, the results are not that great when I just scale the image using the built-in scaling methods. It appears very blurry and really distorted. One useful technique that you can use is the 9-slice scaling technique, which allows you to stretch your image both horizontally and vertically while retaining your fixed corners of your edge. One thing to note is at this time, in the release of Phaser 3.60, the Phaser 3 library introduced a new 9-slice game object that can be created using the 9-slice technique. However, this feature only works if your game is using WebGL, so if you're using the canvas renderer in your Phaser game, that game object will not actually be created, and so you have to solve for this yourself. If you are interested in learning more about this new game object, there will be a link in the description of this video to another video that goes over how to use this feature, and there will be a link on your screen now to that video. So since this feature is only supported in WebGL, this video will show you how you can apply the 9-slice technique to your own game objects in Phaser 3. Alright, so if you're not familiar with the 9-slice scaling technique, basically this technique will allow you to take a base image and you divide it into 9 parts. And so for your image, what you want to do is define your cuts that you want to make on your corners. So basically your corner cuts here, so for 1, 3, 7, and 9. And once you've calculated that cut by providing your width and height, what you need to do is dynamically calculate the width and height of the remaining pieces. So 2, 4, 5, 6, and 8 here. And so once you've calculated these dimensions, what you can do is when you go to draw out your image, you can draw your image out in parts. And when you draw the parts for your 4 corners, you're going to use your width and height that you defined. So you're using that base image with no stretching. And then for your other remaining pieces, you're going to stretch those images. And so what that results in is your corners are nice and crisp because they're not being stretched. And your other pieces that can be stretched, they still look really nice. Alright, so now we reviewed what 9-slice scaling is, we can go ahead and get started with our code. So in order to follow along with the video, there's going to be some starter code that you can go ahead and download. So in the description of this video is going to link to this direct download. And basically this is a starter code template that has a basic Phaser 3 game set up with some images that are loaded. And it's going to go ahead and draw out image game objects to our canvas elements, like what you see here. So if you want to go ahead and follow along with the video, please go ahead and download that code now. Alright, so once you download that code and open in your IDE of choice, what you should see is the following folder structure. There should be an assets folder that's going to have a couple images that we're going to go ahead and use for this demo here. So we're going to have this glass panel and then the UI panel that we see now. There should be a source folder, so this is going to have all of the JavaScript code for the template. So your main.js file is the main entry point to our code. And this is where we create our Phaser 3 game instance. And then our types just has the Phaser 3 type definitions. And then our library just exports out the Phaser library. Finally, we have our index.html, which is just our basic web page where we have our Phaser 3 library. And we go ahead and reference our main JavaScript file. So going to get started, let's jump over to our main.js file. Alright, so to go ahead and draw out our image, what we need to do is we need to create 9 image game objects. And for these image game objects, what we need to do is we need to define our texture that we want to apply to them. And so in Phaser, when we go ahead and load in our image asset, what this is going to do in our texture manager is this is going to create one base texture, which is the whole image. And we can go ahead and use that texture when we create our image game objects to render that to our scene. However, for us to scale our image properly, what we need to do is we need to break that texture up into 9 parts that represent our 9 pieces that we want to go ahead and render out to our screen. And so to go ahead and do that, what we're going to go ahead and do is in our create method, let's go ahead and comment out our initial scaled image. All right, so to go ahead and get started, the first thing we need to do is we need to get a reference to that texture that's tied to the image we want to go ahead and render out. So to go ahead and do that, let's make a new variable. We'll do const texture, and this is going to be equal to this. So our Phaser 3 scene, our systems manager, and then we want to go ahead and grab the texture manager. And then from our texture manager, we can use the get method to get one of our textures that's now being cached. We're going to go ahead and reference our asset keys, and then we're going to do panel. So basically, asset keys is just an object that has a property for the asset name that we want to use. So when we load in our assets, we need to provide a unique key for that asset, and then we want to render out that texture to one of our game objects. We need to use that same key. So that's what we're doing here. And then what we're going to go ahead and do is let's go ahead and console log out our texture. And so we can go ahead and take a quick look at it. All right, so if you go ahead and open up your developer console, we should see a new object that represents our texture. And so your texture in Phaser 3 is basically going to be your image or your sprite sheets that you load into your game. And when you do an image, basically it's going to only have one frame. And that frame is going to have a unique key called base. And this is dynamically added by Phaser. And so your frame is going to have metadata tied to the image data that was loaded. And so it's going to have data on how you can render out that part of the image to your canvas element. And so it's going to have like your width and height, the cut values to know which part of the image to only show. And this will get dynamically created, like if you do a sprite sheet based on your frame widths and heights that you provided. But with images, you'll only have your one base frame, and basically your properties is going to be the full width and height of your image that you load. With your X and Y values of the source image being 0, because we want to draw out that whole image. And so, since we have our texture, what we need to do is we actually need to create our own frames on this texture that is going to represent the 9 parts of our image that we want to go ahead and apply this technique to. And so to do that, now that we have our texture, we need to get a reference to our first frame, to our base. And so what we're going to do is we're going to make a new variable, do const, and we're going to do base frame. And this is going to be equal to our textures. So equal to our texture, our frames, and then what we're going to do is we're going to reference that base frame. And then what I'm going to do is let's go ahead and get rid of our console log, and we're just going to console log out our base frame, and we're going to do our dot width and our dot height. Oh, and then base frame should have 2 underscores. And then, so if we go ahead and save and refresh, we should see our original image's width and height of 96 pixels by 96 pixels. All right, so now that we've seen how we can get our texture from our texture manager, what we need to do is we need to add new frames to our texture. So our current frame has the full image data, and now we need to add in 9 frames that are going to represent our 9 pieces of our image that we want to go ahead and draw out to our scene. And so to do this, we're going to need to define a few properties. And so the first property we want to go ahead and define is going to be our corner cut. And so basically our corner cut is going to be our width and height of the corner that we want to cut out of our image, and it's going to represent our 4 corners. Then we need to go ahead and define our target width and height of what we want the resulting image to be. And then based on those properties, we can dynamically calculate the values that are needed for each of our 9 frames here. And so to go ahead and do that, let's make a few new variables. And so what we're going to do is we're going to do const, and we're going to do corner cut. We're going to set that equal to 32. So we're going to make a corner cut of 32 pixels. So we'll have a rectangle 32 by 32. Then we'll want our target width. And so we're going to say 600 pixels. And we'll do our target height, and we'll go ahead and say 400 pixels. And so this is going to be the target width and height of the game object that we want to draw to our screen, so our image. All right, so now we need to go ahead and add in our frames. So to go ahead and add frames, what we can do is we use our texture, and we can use the add method. And so what this allows us to do, it allows us to add a new frame to our texture. And so to go ahead and do this, we need to provide a unique name or a number for this frame. And so what we're going to do is we're going to use asset cut frames, and we're going to reference our top left value. And so real quick, all asset keyframes is just another object that has 9 unique strings defined on it. And these are going to represent our 9 pieces that we need to cut out of our source image. And so we'll have top left, top middle, top right, middle left, middle middle, middle right, bottom left, bottom middle, bottom right. And so this just gives us our unique string on our texture, so then that way we don't override any textures that were already added. And so our next argument we need to provide is our source index. So for each of our textures, they're made up of our various images and sprite sheets. And so your sources are going to be the raw data that makes up that texture. So in our case, it's going to be our image. It's going to have all of the metadata tied to our image. So when you have just a basic image, there's going to be one source, and so we're going to have index of 0. Versus if you loaded in something that had multiple images that make up that texture, then you'll have multiple sources. So then after we provide our source index, we need to provide our x and y values of where this frame is going to find in our source image. So for our top left corner, that's going to be 0, 0 of our original image. And then we need to define the width and the height that's going to make up this frame. And so basically this is going to be our corner cut, so our width and our height of that we want to cut out of this original image to define that first frame. And so we're going to go ahead and just do corner cut and then corner cut. And real quick, what we're going to go ahead and do is let's go ahead and console log out our texture again, and we're just going to take a look at our updated object. All right, so if we go ahead and take a look, you'll see now we have 2 frames on our texture, and we can see our frames object has our top left key that we added. And so now this has all of the metadata that's needed for this frame. And so basically what we're doing at a high level is we're treating our image as like a sprite sheet. And so now we're defining each of our frames that make up that sprite sheet. And so now that we have our top left corner, we can go ahead and repeat this process for each of our remaining pieces. So what we're going to do is let's copy this line of code, and we'll go ahead and paste it twice. And this is going to be our top row here. And so we'll have our top left, our top middle, and then we'll go ahead and do our top right. And so for these 3 pieces, we'll always have the same source index for all 9 of these actually. And then so for our X position, what we need to do for our middle piece is this is going to be our corner cut. So we're going to say we're going to come over this far, and it's going to be a starting X position. For our Y value, this is going to stay the same for our whole top row, so it's always going to be 0 for our image. Then what we want to do is for our width of this frame, we want to take our base frame width, so the original width of our image, and we need to subtract our corner cut times 2. So basically, when we have our middle piece here, we're taking this corner cut, and we're subtracting those 2 from our total width to get that value. And so we'll take our width and we're going to subtract corner cut, and we'll multiply it by 2. And then for our height, it's just going to be our corner cut because that's just how far down we're coming. Then for our top right, what we'll do is for our X value, we need to take our base frame dot width and we'll subtract our corner cut. So now we're going to take our full width, and we're just going to come back our cut width to get our starting position. Y value will be 0, and now for our width and height, it's just be our corner cut to give us that nice corner piece here. All right, so if we go ahead and save real quick, let's just take a look at our updated code. Well, we'll take a look at our updated texture. So now we have 4 frames, and we see our top left, top middle, and top right. All right, so what we'll go ahead and do is let's just copy these 3 lines of code, and we'll go ahead and paste it to do our middle. So let's go middle left, we'll have our middle middle, and we'll have our middle right. Now for our positions, so for our X and Y, for our middle left, we're going to be at 0 for our X, but then our Y is going to be our corner cut, so we're coming down that far. So we'll have 0, we'll have corner cut, and then so for our width, this is going to be our corner cut for how far we kind of want to come over. But now for our height, what we want to do is we need to take our full height of our image, and we want to go ahead and subtract our corner cut times 2 to get this calculated height here, similar to what we did for our width. So what we'll do is we'll take our base frame, we'll take our height, and we're going to subtract our corner cut multiplied by 2. All right, so then for our middle piece, what we'll do is we'll have our corner cut for our X value. We can also use our corner cut for our middle value. So we'll go ahead and remove. Let's go ahead and replace our 0. And then for our width, what we want to do is we'll keep the same base frame width minus our corner cut times 2. But then for our height, we're going to go ahead and copy what we did for our middle left piece, since it'll be the same height. Then for our middle right piece, what we want to do is we're going to take our base frame width, we'll subtract our corner cut to get our starting X here. Our Y value is just going to be our corner cut because that's how far down we'll come. And then for our width, that'll just be our corner cut, so it's going to be how big it is. And then for our height, it's just going to be the same as our other two frames. All right, so now the last thing we need to do is add in our texture frames for our bottom row. So let's go ahead and copy this logic here, and we'll go ahead and paste it, and we'll update our values. So we're going to have our bottom left, bottom middle, and then bottom right. Then so for our bottom left, we'll have 0 for our X position. Y is just going to be our whole height, subtract our corner cut. So we'll go ahead and do our base frame, our height, and we'll subtract our corner cut. Then we need to go ahead and we'll have corner cut for our width and corner cut for our height, and so it defines that frame. For our middle frame, our X value is going to go ahead and be our corner cut, so we'll come over our 32 pixels. Our Y value is going to be our base frame height minus our corner cut. Then for our calculated width, what we want to do is we'll take our base frame width minus corner cut times 2, so we get that value. And then for our height, this will just be our corner cut, so we know how big it is. Finally, for our last frame, what we'll do is we'll take the width of our base image, we'll subtract our corner cut to get our starting X position. For our Y position, we want to go ahead and take our base height and subtract our corner cut, so it's at the same Y value as our other two frames. This will be here. And then we want to go ahead and we'll have our corner cut for our width and corner cut for our height. So if we go ahead and save, let's take a look at our texture object now. And we should have 10 frames. So we'll have our base frame plus our 9 new frames that we've added that make up our whole image. All right, so now we have our 9 new texture frames. We can go ahead and create our game objects, and we want to assign those frames to those game objects. All right, so what we're going to go ahead and do is we're going to go ahead and create our 9 image game objects. So we'll do const, we'll make a new variable, we'll do TL, so our top left image game object will be equal to this.add.image. And then what we need to do is provide our X and Y value of where we want this game object to be positioned. For the time being, we're just going to do 0, 0 for all of our game objects just to get them added. Then we need to provide our texture. So this is going to be our asset keys. It's going to be our panel. And now we need to provide the frame that we want to use. So this is going to be our asset cut frames. And we'll want our top left frame that we defined. And then we're going to go ahead and call set origin to position this in the top left corner instead of the default of the middle. And then what we're going to do, let's just copy this line of code, and we're going to create our 9 game objects. And let's go ahead and update our names real quick. And so we'll have our top middle, we'll have our top right, we'll have our middle left, we'll have our middle middle, and then we'll have our middle right. Then finally, we'll have our bottom left, we'll have our bottom middle, and our bottom right. And then we'll go ahead and update our frame reference. So we're going to have top middle, top right, we'll have middle left, middle middle, and then middle right, and then bottom left, bottom middle, and bottom right. And then so with our new image game objects, what we're going to go ahead and do is we're going to go ahead and place these all inside a container. And then that way we can use our container's position to position the overall image that we want to add. So we'll just do this. We'll do add container. And so for our position, we're just going to say 100, 100 for our starting position. And then we're going to go ahead and add in our child game objects. This will be our top left, top middle, top right, middle left, middle middle, middle right, bottom left, bottom middle, and bottom right. That's our 9 image game objects, and they'll all be placed in our container. All right, so real quick, what we did here is we added in 9 new image game objects. Basically, for each of these game objects, we went ahead and positioned in the same position. We referenced our asset that we want to use, and then we referenced our brand new frames that we defined up here. Then for each of these images, we add them into our container, which we can then position all of our game objects at one starting position and position them relatively inside that container. And it's just going to make it a little bit easier to work with each of our image game objects. And so if we save and take a look at our scene, we now see one image on our scene. And basically these are our 9 image game objects that are being rendered on top of each other. And so what we'll want to do is we need to go ahead and update their positioning based on where they should be positioned in our container. And so for our top left image game object, that's going to be position 0, 0. So we always want our top left to start here. Then for our top middle, what we need to do is we're going to take our top left's display width, and we're going to go ahead and use that as our starting position. And so with our display width, that's going to allow us to use our width that's dynamically calculated from our frame here. Then for our top right, what we're going to do for our X position is we're going to use our top left's display width, and we're going to add our top middle's display width together, so then that way we have where that should start. So if we go ahead and save and take a look, we'll see now we're starting to get the form of our original image here. And so what we're going to want to head and do is do the same process for our middle row and then our bottom row. And so for our middle row, our X is going to go ahead and be 0, but then for our height, this will be our top left display height. We'll want to use that as our starting position. Then for our middle piece, what we'll want to do is take our middle left's display width and use that for our X position. And so we'll just go ahead and update this to middle left. Then for our Y position, we just copy the Y position of our middle left game object. Then for our middle right, we'll go ahead and do the same thing for our Y value. So we'll use our middle left Y value. And then so for our middle right X value, we'll want to copy what we did for our top row. And so instead of our top left, we'll do our middle left display width and our middle display width, add those together to get our position. And so if we take a look at our scene, we can now see our middle row is being positioned correctly. So then finally, we just need to do the same thing for our bottom row. And so for our bottom left, we'll have position 0. Our Y value is going to be our top left display height plus our middle left display height to go ahead and get our Y position. All right, so then for our X value for our bottom middle piece, we'll want to use our bottom left display width to get our starting X position, and then for our starting Y, this is going to be, and then for our starting Y position, we can copy what was used for our bottom left Y position. For our bottom right, for our Y value, we'll do the same thing. We'll have our bottom left Y position, and then for our X position, we want to go ahead and add together our bottom left and bottom middle's display width. So we're going to go ahead and copy this and paste it, and let's add in our bottom left, our bottom middle display width. All right, so go ahead and save and test our changes. We come over to scene. What we should see is our original image being drawn to our canvas. And so what we've done is we created our 9 image game objects, and we associate our frames that we defined. And because we just used the raw frames and we didn't stretch them, that results in our original image being displayed. And what we need to do now is for 5 of our image game objects, we need to go ahead and stretch them. So then that way we get our resulting image that is the size that we want. So as an example here, for our top middle frame here, instead of being the original square, we want to go ahead and stretch it horizontally. So then that way we can get our target width by adding our 2 corners with that piece together. Likewise, for our middle pieces here, we want to stretch them vertically, so then that way we get our resulting height. One unique piece will be our middle piece. We need to stretch that both horizontally and vertically, so that we'll need to go ahead and fill in the gap to get the overall height we're looking for. All right, so go ahead and do this. So we'll do this in our code. We'll need to go ahead and update our top middle game object. And so for this one, we need to update our display width to go ahead and stretch it. So we'll do our top middle. We'll do our display width, and we're going to set it equal to our target width. So this is going to be our width that we want our whole image to be. And we need to subtract our corner cuts times 2. And if we go ahead and save, what we'll see is now our image is now stretched because we updated this display width to be dynamic. And now we just need to repeat this process for other rows. So for our bottom row, what we want to do is we'll also update our display width on our bottom middle game object. So go ahead and save. We should see now our bottom middle frame is now stretched. And then what we'll need to do next is we'll need to update our display height for our middle row here. So what we'll do is on our middle left game object, we'll do our display height is going to be equal target height minus our corner cut times 2. Go ahead and save. We'll see now our one frame is now being stretched vertically like we want. And then so what we need to do is we'll need to update our display height for our other two game objects in our middle. So let's go ahead and copy this here. Go ahead and paste it. And we'll go ahead and set this equal to our middle left display height. And we'll change this to middle. Copy this. Go ahead and paste. And we'll do our middle right. All right, if we go ahead and save, now we'll see that our right side is stretched properly. And now we just need to update our display width of our middle frame, our middle game object. So what we'll do is we'll copy this line of code here, and we'll place that here, and we'll update the reference to be middle, and so we'll have our target width minus our corner cut. All right, so go ahead and save. We should now see that we have our full image being rendered to our canvas element by using our 9 image game objects. And we can see that our corners are no longer blurry. They're nice and crisp like our original image. Go ahead and see a comparison. Come back to our create method. Let's uncomment our line of code that's tied to our original image game object, where we're just using the scaling method to go ahead and scale up our game object. And so we can see that our new image is much more clear and crisp. All right, and with that actually wraps up our code. And so what we've done here is we've seen how we can use the native functionality of Phaser 3, so our image game objects and our texture manager, to go ahead and apply our logic for the 9-slice image scaling technique to go ahead and create frames for our image dynamically, and then use those frames to render out our image and scale it and have it look very nice using that 9-slice image scaling technique. And so just to give credit to our assets that were used, there'll be links to these in the description of the video. From Kenny, we used the UI space expansion pack for our glass panel. And then for our other panel, this was hosted on itch.io. It was created by BD Dragon 1727. And so that was for our panel that we see here. All right, with that actually brings this video to an end. So as a reminder, there is a link in the description of this video to the complete source code for this video. And as always, thank you so much for watching. I hope you enjoyed the content. If you did enjoy the video, please consider liking the video and hitting the bell icon to be notified when the next video in the series is released. For more great Phaser 3 content, please see the links on your screen now.